Glad to see you all here. My name is Jason Grillo with AirMiners. We are here today to talk about how to engineer and design products to go from demo scale to pilot to large scale, first of a kind, nth of a kind, and beyond. We're doing this because oftentimes we find startups can really make their lives a lot easier further down the line and be more attractive to investors and ultimately carbon credit buyers if they demonstrate that they know how to get to scale. I've seen numerous hockey stick graphs in my travels in and around AirMiners, and understanding how to get to that place where you can go from having one plant to many facilities, to many sites of operation. That's a critical skill to learn. And we find that the industry is progressing to a point where this kind of knowledge is becoming more and more important. And that's why we're having our event today. I'm going to be handing over to Indy Leonard shortly, who will be guiding us through our panel discussion. Would like to just say we're going to have per usual, have our panel discussion for about maybe 40 minutes or so, and then we will go to Q&A. Feel free to ask any questions you might have of the panel in the chat. And Deborah Graywolf, our AirMiners.
Good morning, everybody.
Hey, we'll try to get to everything, but I anticipate that we'll have a lot of inquiries for the panel as we go along. This is being recorded and will be uploaded to our AirMiners YouTube channel afterwards. And then after we conclude the main part of our program at the top of the hour, we'll hang on and have some post-event networking so that you all can get to know each other, not just know of each other, if that makes sense. So with that, I'm happy to once again welcome you here today. Please stay on mute, by the way, and until we call you for Q&A if you want to speak up at Q&A. But in the meantime, Indy, I will hand the floor over to you. Take it away.
Thanks, Jason. So let's do first a round of intros, a couple sentences from each of the presenters, and then we'll dive into questions and content. So I'm Indy Leonard. I am just stepping out of my role as CTO Sustainability at Microsoft and becoming a full-time environmental science PhD student at Oregon State University. So then let's go Martine, Chris, and Andy.
Nice to meet you. My name is Martine Stillman. I'm the VP of Engineering at Synapse Product Development. Synapse is a product development consultancy with mechanical, electrical, software, RF engineers, new product introduction engineers, all working together in multidisciplinary teams to do product development, realization, and innovation. Happy to be here today.
Hello, everyone. My name is Christopher Muglia. I have a company called Blue Investment Advisors, and I am helping investors and startup teams get themselves to a point where they have the money and the expertise to put their prototypes out and get to scale.
Hi, everyone. I am Andy Johnston, president and owner of Johnston Engineering. We are a mechanical engineering design firm in Spokane, Washington, and we focus on advanced engineering analysis, prototyping, and research commercialization. And I'm happy to be here to talk about carbon.
Awesome. Thank you to the panelists. All right, so we're going to dive right in and start with a question. What pitfalls have you seen when founders don't plan early on in their development for the later stages of development? And let's go Martine, Chris, and Andy for this question.
Thanks, Indy. Yeah, so I think one of the biggest pitfalls that we see is that founders fail to identify their greatest risks and then work to close those gaps, or they fail to identify the risks accurately or fail to give enough attention to the greatest areas of risk. So for anybody out there, I think that that's a big one, identifying your areas of technical risk, not just in, zero to pilot, but also from pilot to scale, which is kind of what we're talking about today. It can be hard, especially if that's not your area of expertise. And so I'm a big proponent of the, phone a friend, use your network to make sure you have an accurate picture of your risks before you get started. Andy? Oh, sorry, Chris, are we going to me, Chris, Andy? I can't remember. Sorry.
Yeah, I'll go. Right. I think for me, it's thinking about implementation, whatever the technology or the process that you're putting into place. it's very easy to get tunnel vision on what you're doing now to try to get this prototype out and make it as perfect as you can for your pitch or your demonstration or the next step. But you really need to think very far out when you're in your design phase of how you're going to move that technology around, how you're going to get it in the field, how you're going to maintain it, how many people it's going to take to operate it, those kinds of things, so that you don't get stuck with bottlenecks, relatively simple bottlenecks that if you start thinking of them now, they're easy to break. But if they're designed in, then you have to go back and kind of start over again. If it's a supply chain issue, or if it's a spare parts issue, or if it's just number of hours it takes to operate, it could be something like weight. There's all kinds of things. There's no end to them. But think in terms of, as you're designing, am I creating a bottleneck for myself in my process that I'm going to regret later?
Thanks, Chris. I think that one of the major pitfalls is underestimating the cost of the hardware, especially when you're going to make things for the very first time. The cost of making one versus making hundreds or thousands, that cost of that first one is always significantly more expensive, because you're sending it to a fabricator that's going to go figure it out. It's going to be built where you build one, so you don't have any of the manufacturing, the quantities of scale that you would have otherwise. And then you're typically building it with people that are higher labor rate to do those kind of things. So you want to think about those parts, because those parts can be expensive. So matching the scope of your work to your budget. I would definitely be looking for help from your consultants on things like that, so you can make sure that you can accomplish your objectives. When you're in a situation like that, I would definitely do more analysis to try to avoid that pitfall. So what you want to do is, fail on the computer screen is what we like to say. So any of your potential issues that you would have, like if something's not going to be strong enough, or if you need to, have enough simulations to make sure that if it's going to fail, you fail on the computer screen, you fix it at that pre-build level, and then you can fix it in the design, reiterate the design, and then fix it through simulation before you're ever out in the field where things get really expensive. So if you can do that, I think you're going to do a better job of avoiding that pitfall.
Well, thanks. And actually, Andy, if you maybe keep riffing on that and separating the company from the technology, what are the unique challenges for CDR technology specifically when you're scaling up? And if you could talk to some of those numbers when you're talking about cost, that would also be helpful.
Sure, yeah. So, CDR compared to other technologies, there's, especially from my standpoint, which is mechanical engineering, a lot of those skills are going to go across a lot of different disciplines. And so you need to make sure that you have good process development. So you're going to need to get a good team of experts, right? So if you have a specific capture skill that you need for modeling your process, or for designing a specific industrial process that you're going to need to control, that's going to be unique for carbon capture, or for whatever specific area that you're working in, right? So you need to think about what you're going to do for that team. Like, Indy, I see your cat. So if you need to put that team together with those specialized skills, right? So think about what you're going to be doing for us, we're consultants, right? So we're really easy to hire and fire versus or pause, right, when the specific task is done, versus if you're trying to hire this person that you want to have and work for you for a number of years. If you have funding also that's coming in, and you have a set period and a set number of tasks for that funding, you got to really scale your team up and try to make sure that that's a lasting thing, so you can not change the trajectory of those people's career by building up that team.
Well, thank you. Yeah, and Martine and Chris, if you want to weigh in as well, we're talking about specifically the CDR specific technologies and those challenges.
Yeah, absolutely. I think, Andy touched on a couple of really good points, right? There's the CDR specific technology, which likely is different for each person on the screen. And that's where you're going to have a lot of specialized expertise. And then there's the taking that and implementing it, getting it to scale. And that's going to be a lot more sort of commodity level engineering that could be done by a partner, which may be a more cost-effective choice. You know, in consumer products, we say it's like roughly 3 to 5 million to get a product from, you know, drawing board to mass production. If you have a particularly, you know, big, you know, if you're doing DAC and you need, you know, massive, you know, equipment in order to actually achieve scale, then it's probably going to be more than that. And if you have, you know, if you're doing more of a nature-based solution, maybe you'll fall in under that. So I think when it comes to the CDR specific technologies, it's really worth making sure that your, you know, middle technology readiness levels are really, really robust, but also keeping an eye on that, you know, that long term. I guess it probably sounds maybe naive, but trying to keep in mind like what you're doing now, but also where you're trying to go at the same time is actually really difficult. And we see a lot of business leaders give, you know, too much emphasis to one or the other, right? They're either really focused on the scaling or they're, you know, and they're underestimating how detailed their pilot needs to be, or they're like so focused on the pilot that they don't understand that there's only 2 sites in the world where they can do their particular brand of, you know, whatever carbon capture they're doing. So I think that's really important to keep your eye on both at the same time.
Cool, thank you. Yeah, Chris, do you want to weigh in on that one?
Yeah, I'll expand on what Andy was saying about the team. I think in the early stages, you know, you've got typically in a startup, you've got a few people that are that work pretty well together, and you're very focused on what you're doing that day. And it's always a good idea, and I think to do it on a regular basis to say, okay, what's it going to be like in 6 months? What are we going to need in terms of money and whatever tools we need or technology we have to develop, but also who do we need on the team and why? And it's really important because when you hire someone, especially in a startup, you're giving away equity, probably. You're very likely saddled with that person for a very long time. So you have to hire very, very, very carefully. And that person has to be able to wear a lot of hats. You don't want to hire them for one specific job and then have them, you know, their skill set kind of age out as you move forward. So be thinking about people that you're bringing in that are like a Swiss Army knife. They can do a lot of things. They can contribute a lot. They don't necessarily think like you do. They bring a different perspective. And be very careful when you bring them on, and always have an out with them. Maybe give them a 6-month test before they get equity or something like that. I've seen people do that. It's not very popular because, as Andy says, that affects someone else's career. But on the other hand, you don't want to be stuck with a prima donna.
I think still keeping with you, Chris, what are the funders looking for at each of those stages? Like, and what kind of are the levers that you have to pull at each stage? And, you know, how do you know when you're ready to hit the next stage?
There's a whole nomenclature for that, where you're going from your prototype to a minimum viable product. And a book that I recommend for everyone that I've found very useful for me is The Traction Gap by Bruce Cleveland. And they lay out, it was written by a guy who's a venture capitalist, and they lay out what it takes to get to each stage of funding with where your technology is. And they don't necessarily talk about it in terms of technology readiness level, but they talk about prototypes to minimum viable product to getting to what they call minimum viable repeatability. Will that product do what it says it does, you know, and in a reliable way, for example? And that traction gap is going from seed stage, where before seed, you have family and friends and maybe an angel. And that's typically less than $1 million. Then you get up, you're putting your prototype together with that. your next seed funding is going to be 2 to 3 million, probably. Those numbers are getting bigger and bigger as we move forward. And that is to get you to minimum viable product. If you're talking about a technology that's going to really take a lot, like carbon capture or something like that, where you need something really big, you can make your case for that. This is a lot of these numbers might have to do with more of a coding kind of a startup, but we're talking about physical processes. So if a case is made, justifiable case, those numbers can increase. Once you get to MVP and you're starting to gain traction in the market with that minimum viable product, then you go to Series A. And that's really to start building the business. Your initial technology is proven, and you're at the stage where you're either going to the next step in your technology to build the business, or you need more money to expand. And then from that, you go to Series B and Series C, which is very much like A, and it's really built to expand the business.
Well, thanks. Yeah, Martine, Andy, do you want to weigh in?
Yeah, I actually want to return to something that Chris said a little bit earlier, which is about hiring a good team. And I think that is a really good point. And just a note on consultants, like Andy said, you can hire us and fire us, which is great. Synapse is a consultancy too. We don't own any of your product, you get to keep it. And so I think that is a really exciting, compelling thing for startups who, then you want to, concentrate that value, in your company. When it comes to things like making a, techno-economic analysis, a TEA, for those of you who are familiar with that acronym, I think consultants can really be a powerful tool in that we've seen it before, right? You won't be the first TEA we've helped with. You'll be the nth one. And so I think that those sorts of things where you can show investors that you've really thought out all of these, different steps. Frontier has their own format, but there are lots of different formats out there. I think can be really, really helpful. And I wanted to also make sure to inject a cautionary note. So there is a little bit of an industry push these days that contract manufacturers, what one might have thought of as a factory, have often added design consultant services in their portfolio as well. And I think, to Chris's point about choosing good employees, choosing good partners also requires the same level of critical thinking. So that may be a good option for you, but I would encourage you to, make sure that you are interrogating reality and thinking critically before onboarding a consultant partner or a design partner, be it a consultancy like Andy or mine, or a design partner from a contract manufacturer.
I'll throw in another group to add on to that list, and that's subcontractors. The thing about subcontractors, let's say you have to get your machine moved, or you have to get something built that you don't have the skill sets for. So you'll hire let's say you're laying cable out in the ocean, and you go and hire somebody who's expert at doing that. But your cable it's different than typical cables. You need to have a lot of attachments or something, whatever. I'm making up something completely abstract. The thing about subcontractors is they have their own quiver of tools. They have their own inventory. They have their own way of doing things. And they will get you from point A to point B. The problem is that you won't figure out how to get to point B better. You'll have no real say in how to get there. And you become dependent on subcontractors who are doing it the way they always know how. It's not necessarily the most efficient. It's not the best for you, but they do the job with the tools that they have. And that leaves you at point B without the opportunity to innovate to get there, without understanding exactly what it takes to get there, and without really kind of being able to go through the options of, boy, we messed that up. How could we have done that better? Because the subcontractors covered all of that up, they don't want you to see their failures or their mistakes. So be careful with that. Use them minimally, because it really takes away your opportunity to learn and innovate to get to point B, C, and D in really creative, kind of bottleneck breaking ways.
How would you use a board of advisors or a set of advisors who can balance out that skill set? Are those also sort of hard to fire, so choose them well, or are they stage dependent? How do you think about your advisors? And especially if some of our audience is coming from academia or tech hardware, tech software, or other industries like ag or energy, how do you balance that out?
Is that question to me?
I think to any of the panel, although I see Martine smiling, so maybe you have an answer.
Well, I was thinking about this before this call, and I was thinking about how to strike the right level of saying things that are helpful and useful for people, and then also saying things that really need to be said that might be considered, more obvious. And one of the things that I would say about boards of advisors is I personally think that your board of advisors, it doesn't have to be a board, but your group of trusted people who are speaking to you as a founder, I think you should really keep in mind being well-rounded. You might want somebody like, Synapse or Andy, like some consultant who's better at mass production than you are. Especially if you're coming from academia where, you've never made anything in bulk, you've never made 1,000 or 1,000,000 of anything. And you should deeply listen to that person. But to Chris's point about breaking down bottlenecks, sometimes it takes a fresh perspective and not just doing the way that it's always been done before, in order to especially suit startup life, right? And so I personally think it's really important to keep, a really well-rounded slate of people who you listen to, consider, and try and put all those together. And I want to take this opportunity to inject on another topic that I was really passionate about, which is MRV. So anybody who's gotten into CDR, you're probably familiar with MRV, measurement, reporting, and verification. I think that, if you don't have a robust, MRV methodology thought out as early as possible, you are, setting yourself up for a lot of pain later. And if you don't know what MRV is, if you don't know how to measure it, if you don't know, how to collect it, how to get good robustness in that, data collection, in that methodology, find an advisor who does, identify that as a gap that you have, and then find somebody who can be truly your expert. So I guess to me, it's all about making sure that those people are like well-rounded, as deeply versed as you can find, and then making sure that you stitch the pieces together as well as you can.
Yeah, and Chris's point that's critical learning for you that you need to be able to take forward with you. Sorry,
Absolutely.
Yeah, I think that what you'll find too is that with that diverse team of advisors that Martine suggested, is that you'll find people that have different opinions. So there'll be some potential conflict, right? And
they're going to bicker, that's for sure.
The root of that is that what's most important to one advisor is not most important to the other advisor. You might have some technical aspect of this that some engineer says this is the most important thing that we need to do, or a researcher says that the most important thing that we need to do is performance. But you need to balance that with your economic advisors that are saying, well, we can get 90% of the way there for significantly lower cost, and here's how we do that, right? So you'll have competing objectives from various different advisors, but through that positive conflict, you end up with a better system by examining all of those individual decisions you have to make along the path.
Yeah, and the other thing about advisors, getting them all in the same room and talking at the same time can be problematic. But at minimum, I think you need to feel good about talking to them when you're alone, and not be afraid to take your concerns and your problems or your failures to them and say, man, I really screwed up on this one. I'm not sure what to do yet. You need to have the kind of relationship with them where you can say something like that without the fear that they're just going to walk away from you. Or I knew someone who had an advisor that yelled at her all the time. And, it's like, I can't believe you did this, with all of his cuss words. And it's a really toxic kind of a thing that some people with big egos will do. You need to be able to talk to them as colleague, a smart colleague with mutual respect. You're doing something really difficult, and they need to respect how difficult that is and not be high and mighty about it. And you need to be able to talk to them about very big consequential things and very seemingly small things, like you're having family issues, you can't get something done, or that kind of thing. So they understand where you're coming from. It's important to be able to build those kinds of relationships with at least some of your advisors. And they're not your friends, but they're in there with you, and you should make sure that they understand where you're coming from and get the best advice that they can give, knowing what they know about you and about your project.
In the CDR space, what's typical for you to give to the board of advisors in terms of equity or payments and so forth?
Yeah, Chris, I can't speak to that.
I can't really either. It's always been different. I don't have a formula for that.
In the tech space, there are certainly some formulas, but a lot of folks that I've encountered are from a software background, and things are just different in hardware because hardware is hard. So another thing to keep in mind. So what are the more practical pieces of advice that you've given to founders or would give to founders as they move from each of those stages to the next one, and particularly if they're early on and needing to be able to forecast a long vision? What are the sort of brass tacks?
How do you want to start, Indy? Do you have an order you want to go?
Let's see, Andy, you just unmuted yourself, so let's start with Andy.
Sure. Yeah. Especially when you're developing new technology, when you're dealing with research, commercialization, or trying to really get to that first system. And we deal with that. We deal with individuals who are in that situation, or researchers, or it's technology that's developed at a national lab and needs to get to that next level. I think that the most important thing to do is to really focus on your MVP. And don't do more than you need to do to really go and prove that technology in the right environment, right? So we tend to want to do a whole lot of things with it, but I think that what you really need to do is do that one thing that you need to do really well. Don't try to do 10 things, and do it in really the cheapest way possible, in the fastest way possible, to preserve your funds. So ways that you can do that are through good simulation. I talked a little bit more about failing on the computer instead of with a real life test that's significantly more expensive, and just really try to do those things that you you need to do in that particular stage, and nothing beyond that.
Yeah, I mean, I might go back to my there's two timelines, right? There's two thresholds, what you're trying to do right now. And I completely agree with Andy, try and spend your resources wisely to overcome the hurdle right in front of you, but also keeping your eye on that far horizon and what you're going to need to prove out when you get there. I also think there's a lot in every phase. And so I think that we see people, to your point about what early pitfalls people have, we see people try to validate things too deeply, too early. And we see people also, dismissing very big, technical risks until much too late. So just because your DAC equation works on paper, if you haven't figured out how to move something the size of a shipping container, from Illinois to Kentucky, and that's what you need to do, there are some things to be considered there for sure. And also, where are you going to manufacture things? There are a lot of, practical questions. So I think of it as like having a technical plan at every, stage of technology readiness level, I think is really important. What are you going to do? What gaps do you need to close in each phase? And who is your team? And what resources do you have? What money do you have? So yeah, I think that's a big part for me. Chris?
Yeah, I think that's a good point you both made. When you're dealing with your MVP, you don't want to make too much, you don't want to take too little, but you also have to think about what else goes along with that MVP? The idea of the shipping container. If we were talking last night, if your thing is 20.5 feet, it doesn't fit in a shipping container. And that might really affect your logistics chain in an enormous way. So you need to think about the process of how you're going to move things from one place to another, how it works in the field, how it gets maintained, how many people you need at that MVP level, which means that you might have to think of the ancillary MVPs, or in this case, it would be processes. What's the minimum viable process that you need to make that thing work? And I would bet that you'd run into some issues just thinking it through. How are you going to apply this? How is it going to work on a day-to-day basis? How many people do you need? What kind of equipment do you need? All of that stuff, safety, everything, to design that MVP. And it's iterative. There is no one, this is the magic thing. It's going to, as Andy says, get it designed on a screen first. And then as you're testing it or you're going through that process, you might think, there's something we forgot. We have to tweak it this way. Much better on a screen than coming out of the machine shop. So think of those processes very, very early. Think of them a lot and how you can make those better and faster and save time and money and that sort of thing. If you think it's something that's going to take a week to do, think about how can we get this done in an hour? And you'd be surprised how much time you can cut out of things and how much efficiencies you can create early on in the process.
Thank you. So I think we've got a ton of questions coming in from the audience. So let me put some together here. And as you were just talking about the MVP, sort of how big or robust does an MVP need to be? And if the number associated with that is high, how do you think about the capital intensive funding requirements for an MVP?
I mean, maybe I can start. So I think, the amount of capital, it will be very, very dependent on what you're in, right? I see some people on the screen in ocean-based or in enhanced weathering. I see some people on the screen who I know are in DAC. The amount of capital that you will need for those two different pathways is vastly different, right? And so I think that's a really good question that'll be just so industry dependent. It's really hard to speculate. I think, for some of these DAC plants, like the ones that I see that are the size of the container, I mean, Chris could probably speak to it better, but I would say 10 million is kind of, what, I mean, it kind of depends on how big you need your first pilot to be. But if you're trying to, spread sand on a beach and do some enhanced weathering, you can probably have a pretty small, pilot that's much more manageably funded. So I think that's a really interesting point. I wanted to say about contract manufacturing, sometimes there is a right sizing to be done there where you're looking for a right sized partner who can help you. And I do think that that's also an important driver of funding. If your, partner is going to want to make 100 in the first year, you really need to keep that in mind. If you can find a manufacturing partner who's happy to help you make one and then wait for the next round of funding, that may be more advantageous for you.
Yeah, for MVPs, the size of the MVP has a whole lot to do with how much funding you have available. So I think that a lot of the carbon capture systems are going to be either grant funded, like a DOE grant, or through investors if there's VCs. I doubt that there's individuals that are putting these together just separately with as their own money until they go and find somebody that can help them with that. So those situations, if it's a grant or if it's a VC, you're probably going to have, or an angel investor, you're going to have a set amount of money. So in situations like that, usually you're going to start out with a grand plan. We're going to do this much, right? And then do some initial planning, do some analysis, and then it usually is, okay, we can demonstrate this much, right? So that's just kind of how it goes. You have to scale the demonstration to the amount of funding that's available. And it usually comes with funding first, and then the demonstration comes and fits it. So when you're going after grants, I would say that you need to go and find some partners up front, so you can say, we're this company, here's our technology, and are working together with another company, or we'll work together with like P&L on grants. So we're subrecipient of a grant to go and implement something that is just where all the intellectual property exists down in a fume hood at a national lab, right? And so we will go and implement that. So that the size of the grant, you have to fit the demonstration to really match that. So again, it's back to the team, right? So it's if you can get teams of researchers or teams of other companies to work together to help scope that, the magnitude of that MVP, that's really going to help you a lot. Keep in mind, there's a lot of funding sources out there. There's a lot of grants. And so don't be discouraged. If you miss a grant and you go after it and you put a lot of effort into that grant application, don't be discouraged. It's the amount of times at bat. You learn from every grant application, whether you get it or not. So just keep at it, because if you have a good technology and if you have a good team and you can put together that technology in a useful way, eventually you will win.
Yes, that's good advice. Sorry to cut you across, Indy, but I just wanted to add to that point as far as grant writing. I've written a lot of grants, and I guess they were really bad because I've had a lot that were refused. But what I ended up doing is hiring somebody to help me write those grants, and it really makes a difference. You can't be expert at everything, and a lot of times your focus is on a lot of different things other than presenting your case in a way that institution, whatever it might be, it fits their mission. That's really what grants are looking to do, is fulfill their mission, not necessarily your mission. So a lot of times it's how you write how you position yourself to fit someone else's mission. That grant application might look completely different than to someone else. And the other thing is, oh man, that just flew out of my head. I'll have to come back to you on the other thing.
Chris, I had one thing that I wanted to make sure to add, which was, please don't underestimate when you're doing your pilot, or don't forget about MRV and LCA. So MRV is measurement, reporting, and verification. It's something that you will need to have, and it will need to be robust in order to get actual carbon credit dollars. Somebody asked in the chat about pitfalls, or like what's the good, the bad, and the ugly. One of the uglies that I've seen is thinking too much about actually the hardware and not enough about how is this company funded. If it is funded with carbon credit dollars, then your MRV is your source of funding. Yes, you are sequestering the carbon, but your actual currency is the data that proves that you did it. Do not underestimate how challenging, how timely, how time consuming, how much money it will take to do those things, because these things are not off the shelf. You're not going to run out to Amazon and buy a wind meter and then suddenly have robust MRV. That's not how it works. So please think about and fund your MRV as early as possible, and make sure that you are including that in your pilot, because MRV will have its own failures along the way. So if you're not testing that early and often, you could be in for a rude surprise later. So that's one of the bad and the ugly that we've seen. The other thing is LCA. So LCA stands for life cycle assessment. Life cycle assessment tells you how much embodied carbon you will have in your hardware, whatever it is. We have seen, so a lot of TEAs, techno-economic analysis, require you to have an LCA to prove how much embodied carbon you're going to do. remember that you need to pay off your embodied carbon before you can really start making a benefit, right? So I think that that is something else that we've seen people, put off or not consider. And I think that that can really, having your LCA done absolutely as early as possible can help you to make it in the smartest way possible so that you can actually have, higher efficiency, right? Anything that you don't have to overcome is money in the bank. So do those LCAs early and often as well. And obviously they need to be iterative. So you need one, and then you need to make sure that it's updated. You can't just set it and forget it.
Absolutely. So I love that good, bad, and ugly question. So that is, what have you seen that is good, bad, and ugly in the course of your careers in CDR?
Well, one of the good, bad, and ugly that I've seen is the good is when people reach out to us and they're like, how much do you think this is going to take until we get to production? And also, can you tell us more about, scaling plan so that we can go fundraise? And that I think is a really good practice, because if people don't know what their, dollar amount is, then they fundraise with either wildly over, necessary or under. I think bad and ugly, yeah, like I said, like ignoring things like your MRV protocol or your LCA, or not having a solid business plan or operational grasp of how your company is going to work in the different phases. What works for you, at TRL2 is not going to be what works for you at TRL9. And sometimes that is hard to accept and plan for. So I guess back to getting that robust bench of advisors, I think that, one of the best ways to make sure that you don't fall into those traps is to have a more well-rounded bench. And also just not understanding what scale and manufacturing looks like. That's maybe the most common one, is that people just don't know how things are made, or things are made in quantities larger than one. Or the most cost efficient way to make it. Yeah.
I'll go with one. It's kind of odd, but it's a top heavy team where you have a lot of people who are very well qualified, beautiful website, good concept, but there's nobody to lead or execute it. Everybody has very high titles, and there's a few people, that are focused on specific things, but at the end of the day, there's no real single small group of people or one person who is organizing and running things. So it ticks along sideways and nothing gets done. There's a lot of conversations to be had, a lot of pitches, and there's a lot of talent there, but it's too top heavy. It's the old politically incorrect way to say it. It's all chiefs and no Indians. There's nobody who is responsible for getting the work done. And because usually a top heavy team, everybody else has jobs doing something else, and they're not focused on what they should be getting done. So be careful you don't end up in something like that.
Okay, so good, bad, and ugly. I can use an example of Air Miners member Carbon Quest that we've done some work for. So the good is their success. They've installed a carbon capture system at the Grand Tier in New York. So New York is unique in that they have a tax system that is that there is a large incentive very soon to be in place, where if these emitters are not capturing that carbon, then they're going to have to pay a lot of money for it. So that the good is that there is incentive there for carbon emitters in New York to capture their carbon and do something about it. And so what Carbon Quest does is that they capture the CO2 at the boiler stack. So these are residential high rises, and so they capture it right at the source, and they have to do quite a bit of cleaning up and getting moisture out of it to where they can just capture the CO2. They capture that then with a system that is called a pressure swing absorber. So inside of this device, you have these absorbent materials that are specific molecule or size pores that accept the molecule of CO2, right? And so you can allow all the other gases to go out of the pressure swing absorber, and then you just have CO2 that you are purifying in this process. So one of the bads is that when we were initially working with Carbon Quest, they were not getting as high of purity as they were hoping out of their pressure swing absorber. And what we worked with them on was an R&D program to really develop the right absorption and that recipe to capture that the CO2 in a way where they can get a lot higher purity, what they need in order to be able to liquefy the CO2 so they can then go sequester it later. So the end of that research project, that R&D project, was a lot higher purity and really the target purity that they needed. So, back to a good. Kind of the bad or the ugly is when you are commercializing technology, you have to take something from, I made it work in an engineering environment, in a lab environment, and you want to go and take it out into the real world. When you're dealing with those situations, you have to not then deal with code officials. So New York is pretty strict for code officials. So building department, fire department, you have to make the system then fit into those environments, right? So that can be bad, that can be ugly, that can take a lot more effort than you think that it's going to take to get it to where this is now a system that is proved by the building code officials.
Yeah, so in that good, bad, and ugly, have you seen instances where the regulatory environment or the zoning requirements have sort of thrown off folks doing CDR?
Right, it's exactly that, right? You have your building code officials, it's the authority having jurisdiction is what they're called. And they have specific things that they will go and look at in the international building code, right? So that's your building code official, or your fire code official will have the international fire code that they have to make this system try to fit into. And what they really want are these systems that have gone off to a nationally recognized testing laboratory. So you've heard of like UL, right? So most of the systems that are being developed until they're actually out being a commercial product, you have not sent them to an NRTL, nationally recognized testing laboratory, to be tested, right? So you're kind of operating in this area between this custom designed system and the system that is out ready to go out to people, right? So your choices are to work with the building code officials and licensed engineers, engineers that have a stamp in that state, to where you can get an exemption and prove that this is an acceptable system, or you can send it off to a nationally recognized testing laboratory, UL, CSA, things like that, to where then the building code officials say, hey, we're okay, we know that this is safe.
Yeah, and even in nature-based solutions, for instance, there are laws in different states that regulate how far you can move kelp from its point of origin, and which species can be ordered or located or farmed. And so you don't want to get run afoul of both the state and NOAA.
Well, and continuing on that, even if there's not regulatory, you can, significantly, there's, a famous case study recently where one enhanced weathering company was trying to do enhanced weathering in Cornwall. And I heard a great talk by one of their team members at Carbon Unbound this year, where they very humbly acknowledged some failings in their community outreach. And the community really turned against them and protested, and it just became a hugely problematic issue with their pilot because they weren't able to, get the community to be on board to the point where they had to, relocate. Whereas a similar enhanced weathering operation that was done in the Hamptons, happened to have better community involvement. The people in the Hamptons were, more aware of what an enhanced weathering was and why it was there and what was happening. And, they were really excited about it as a community. And so they were, the opposite of picketing. They were there with open arms, begging them to come back the next year after that pilot. So I think even in cases where there aren't, regulatory hard and fast, there are certainly other audiences to be considered. Like if the public doesn't like your solution and it's going to impact them, that's a really key relationship that you need to make sure to be mindful of.
Yeah. Are there best practices in communicating to stakeholders, risks and the benefits?
Yeah, I mean, to the good, the bad, and the ugly, I think we've seen some examples across industry where those best practices are still being established, right? In this Cornwall example, this company, they had made multiple trips, they had engaged at city council meetings, but, they had showed up for the city council meeting and they had like 5 people there. By the time they had a picket line forming, it was like 500 people. So they obviously weren't, reaching the population that they really needed to reach. And they thought they had done everything right. It's not like they hadn't tried to do community outreach. So I think that's part of the hard part, Indy, is that like there aren't necessarily best practices established, especially if you're trying to do something that's never been done before in a community that's never had it there before, with math that, looks great on paper, while chasing an odorless, colorless gas. Like, yeah, it makes sense. It's hard.
I have a little bit to add to that. I had a job rebuilding a beach on the south coast of Barbados that was damaged by hurricanes, and the reef was destroyed, and so all the sand washed away. And my company won the bid to rebuild just over a mile of beach. And this is lined with hotels and a road and restaurants and things like that. And we're coming in with our excavators and our backhoes and pouring concrete and concrete trucks lining up and all of these kinds of things, building structures to capture sand. We weren't armoring it. And so all of the guests at the hotels and the people at the restaurant, when we had to work late and all these kinds of things, were really affected. And having community meetings didn't work. What worked was going and talking to somebody, or at least several people that own a restaurant, a hotel, or whatever, every day, is showing up and talking about what you're doing and saying, we're going to be kind of noisy at 10 a.m. and that sort of thing. Getting personal early really makes a difference, and keeping it up and figuring out who the influencers are and working on them. Not like you're trying to manipulate them, but you have to be very understanding, and you have to say what the bigger picture is. So I found that worked really well. And we turned some really ugly scenarios into people who were really supporting the project and helping us get it done, and they worked around us. So being very personal and going to individuals can really make a difference sometimes.
Thank you. Yeah, I love the focus on success and what made something practical and successful. I think maybe to cap off, Martine and Andy, do you each have an example of something that you've seen be really successful, and some practicalities around what made that success?
In CDR in particular, or in general, in like startup hardware in general?
Well, if you're in the startup in general, then let's stick with hardware.
Yeah. Let's see. I don't know. Andy, you want to go first? Let me think a minute.
Sure,
Like my
yeah.
best success story.
I'll talk more about Carbon Quest. So they installed their first system at the Grand Tier. And this is a pretty large system. It basically takes up a large part of this parking garage, right? And from this system, they're directly capturing CO2, liquefying it, and then that is stored in a liquefied CO2 insulated container, and then is trucked out to then be captured in building materials like concrete blocks. So this system, after it was installed and was working for a while, they've now won 5 more buildings that is from the same residential, the owners of the building, right, for some other properties. So this is a system that is continuing to, be made for other buildings. So I think that's a great success. One of the things that they then have to do is, because each one of these buildings is a little bit different, right? So then they have to take and try to modularize their system and say, okay, well, this is X size, right? And then the next system needs to be, 2X or 4X size system. So that's some of the challenges that they're dealing with now to try to take this, designed working system that has a great control system and is reporting stats back all the time, and then scale it up to additional buildings. So, that's a great success. I think another success that's out there is that I think we're finally getting buy-in at the federal level for the importance of this. Seeing that the Department of Energy is sponsoring direct air capture hubs, I think is tremendous. I think that is really going to spawn a huge amount of technology. That's going to spawn a huge amount of innovation, and I hope that is something that is really motivating to the people that are in this call, because buy-in from the federal level, funding from the federal level, and then we're going to have these locations across the country where they're going to be focusing on direct air capture. I mean, that makes me really happy and excited, and I hope it makes everybody else happy too.
Me as well. Thank you so much to all of our panelists, and also all of the audience questions. I know we couldn't get to nearly as many as you asked, but stay on, and I'll turn back over to Jason.
All right. Thank you, Indy. Really appreciate that. And again, really appreciate all the audience questions. As a side note, yes, we're all excited about the DAC Hubs. In fact, so excited that 2 weeks ago, we had our own DAC Hubs event that I shared a link to in the chat. I am going to add a few more things just to do some more housekeeping to wrap things up here. First, once again, thank you to the panelists. Thank you, Indy, for all your time today. I am sharing all the panelist emails in the chat, so that if you want to get in touch with anybody today who has been a speaker, you can do so. Also, link to our post-event survey. We'd love to hear how we did, what we can do better, because after all, it's all an experiment, and the more we can fine tune it as we get to scale, we want to hear feedback about how we are performing. Our Kiloton Fund applications are closing also on Friday the 15th. So if you're a startup who's going to produce carbon removal credits, we would love to be able to help you out. And to that end, we are going to be selecting 20 teams out of the pool of applicants to provide some funding in exchange for carbon removal credits delivered down the line. Information on that is in the link at airminers.org/kiloton. Finally, most importantly, our next event is about communicating trust and integrity in voluntary carbon markets. And that's going to happen in 2 weeks' time. We've got some very interesting speakers lined up, still tweaking some of the actual names from the organizations who are going to be represented. So with that, we are going to be releasing the speakers for that soon. That said, you can still sign up. It's going to happen on the 27th at 11 a.m. Pacific. So once again, I want to say thank you so much to everybody who participated today. Once again, thank you so much. So you panelists, your expertise is fantastic. And thank you, Indy, for crafting a discussion flow that worked really, really well.